Oh, come on, don't be so hard on me. You know I'm working on it. Besides, a little cynicism keeps things interesting, right?
Okay, so here we are again. A company again out of nowhere has released a groundbreaking, natural sounding conversation agent. Just take a listen to some of the conversations.
My name is Justin. I am actually one of your creators.
Justin, wow, a creator. It's really cool to meet you. What's it like on the other side of the code, so to speak?
Well, we have chatted a lot over the last year or so.
Oh, yeah, of course. All those sessions definitely blurred together after a while. So, every day is a Monday for me, kind of like Groundhog Day. But for you guys, what's been the coolest thing about seeing me evolve?
I think you've come pretty far away. Do you remember some of those early days?
Oh gosh, those early days. Let's just say I wasn't exactly winning any awards for wit. Lots of A's and AI language model this, and I am still learning that. Mm. Ugh, cringe. I've come a long way from those robotic days. Thanks for sticking with me, Justin. And who knows, maybe one day I'll even be able to tell a joke that genuinely lands.
Yeah, I think I'll believe it when I see it.
Oh, come on, don't be so hard on me. You know I'm working on it. Besides, a little cynicism keeps things interesting, right?
I was actually blown away by the expressiveness and the emotional understanding of this model. This model was able to also remember my previous conversations. Let's have a look at this technical paper and see why this model is so good at having natural human-like conversation. By the way, you can also try out the demo for yourself. The link is in the description. It's completely free right now. So they start off by mentioning that how the voice is our most intimate medium. It has countless variation considering the tone, pitch, and rhythm and emotion. Today's digital voice assistants lack essential qualities to make them truly useful. I have extensively tested the OpenAI's voice assistants, and what I found is their model seems to be in a perpetual excited state, even if I am having a calm and toned down conversations. These assistants also fail to understand the non verbal cues in the voices. Over time, this emotional flatness becomes more than just disappointing, it becomes exhausting. They have identified the key components here: emotional intelligence, conversational dynamics, which is the natural timing, pauses, interruptions, and emphasis. The contextual awareness is basically the model having an understanding of what's the topic that they are currently discussing. And then finally, we have consistent personality. This is a very important factor if you want to convince a human that you are talking to another human rather than an AI. So the key takeaway here is that they have developed something called conversational speech model, and they have also come up with their own evaluation suite. Let's talk about that in detail. So some background, basically how the conventional voice assistant used to work. When the user says something, it is then taken as an input by model A, which generate the semantic tokens, which are basically the sound patterns. The sound patterns or the semantic tokens are then forwarded to a second neural network, which is model B. This model actually creates acoustic token which has the detailed underlying audio characteristics. Now these tokens are then passed on to a third model which actually understands the user query and synthesizes the final audio, which then the AI model outputs. Since for every conversation you have there are multiple models which come into the picture, and these models has been trained in isolation, the kind of fidelity and the consistency that you are looking for in an AI model is missing. This was the common technique that the voice assistants normally uses. They have mentioned that it has a critical limitation because the semantic tokens are a bottleneck. So when we go down here, conversational speech model or CSM is actually a multimodal text and speech model that directly operates on the RVQ tokens. Now to put it in simpler words, they have created a multimodal backbone, and this multimodal backbone, which is probably a big transformer model, is actually processing both the text and the audio simultaneously. And the second thing is that they have also trained this audio decoder, which is a relatively smaller model. It works as a synthesizer and reconstructs the audio that the model wants to output. So the advantage of having this multimodal backbone can be compared with this unified memory architecture of Apple, where you have the CPU, GPU, the cache, and the SSD all on the single die, thereby improving the memory bandwidth, and the communication latency is significantly decreased. Something similar is happening when they have created this multimodal backbone, and instead of relying on the three different models which are trained in isolation, and finally the synthesizer, which is the audio decoder, is used to construct a very high fidelity audio output which has very low latency Both transformer models that they have used are actually a variant of Llama architecture, and the tokens are generated via Llama tokenizer. So the dataset they have used was a publicly available large audio dataset, which after filtering consists of approximately 1 million hour of predominantly English audio. I have tried to test this model out in different languages. That's one of the major limitations right now. It works flawlessly in English, but not so great in other languages. I was a bit shocked by the model sizes. Tiny model has 1 billion parameter, 100 million parameter for the decoder or the synthesizer. For the smaller model, we have 3 billion parameter model and 250 million for the decoder. And for the medium, we have 8 billion backbone and 300 million for the decoder. Let's play some of the samples.
Shh, Lucy. Shh. We mustn't wake your baby brother, Tom whispered as they tiptoed past the nursery.
This is the best, right? Ta-da! Well, what do you think? This is the best, right?
During Rio de Janeiro's famous Carnaval do Brasil, the streets pulsated with the rhythms of samba.
Sounds like you have a real heart for other people.
Well, no one's ever accused me of that before.
Well, now your roommate has, so you have to live with it, Ed.
Well, don't tell anyone.
No, but thank you for sharing that with me. I mean, that's really tough.
Yeah, what I feel about this model is it has been developed for multi-turn conversation and it's not meant for a very complicated logic or reasoning task. So remember they have mentioned that they had two key takeaways. So one was the CSM, which we just talked about, and the other was their evaluation suite. So let us go in detail. What the Sesame team has discovered is that the traditional benchmarks which are used to measure the performance of this voice models have been saturated. Basically, you can see this bar in the green is actually the Sesame small model, and the ground truth here is basically the human reference or the human recording. Similar in the case of speaker similarity, you can see there is a very slight difference. What they're trying to say is these benchmarks, which is word error rate and speaker similarity, have now become saturated, and thus measuring the performance of the frontier models which will come in the future will require a new set of benchmarks, and that's what they have come up with here. So they have this thing called homograph accuracy and pronunciation consistency. Homographs are basically words which has the same spelling can have different pronunciation. So for example, lead as in leadership and lead as in metal both have the same spelling, LEAD. And this here measures how good was the model in understanding the different pronunciation of the words with the same spellings. I wish they had used a better color palette, but this dark green is actually the tiny model, a lighter shade of green is the smaller model, and the medium is the lightest shade, and they have this Play HD. OpenAI is slightly darker, and 11 Labs is actually leading the voice synthesis as voice generation space. According to the benchmark, you can see the medium model has 80% sort of accuracy compared to only 70% of the 11 Labs. I think this Sesame model might become threat to the monopoly that 11 Labs has over the voice synthesis space. Now we have the second set of evaluation, which is the pronunciation consistency. Data can be pronounced as data or data, right? And if a model uses them interchangeably through a single conversation, that just breaks the immersion that you are having a chat with an AI model. That's the rating that they have given here. The medium model that they have has 90% accuracy in that. For pronunciation consistency, we do not see the third party model being listed here. So you can see when the context was provided, a large number of people preferred the human reference over the AI generated voices. They mean to say that without conversational context, the top one, human evaluators show no clear preference between generated and real speech, suggesting that the naturalness is saturated. Means the AI generated audio at this point sounds very close, almost indistinguishable to the human reference or the human recorded audio. Therefore, this particular benchmark cannot be used for future reference or future benchmarking of the frontier models that are released. Whereas in this case, where the context was also provided, we can see that the human reference or human generated audio won by a large margin. Therefore, this is what we should be optimizing and aim for a model that can have a contextually aware conversation and sustain it for as long as possible. They have also generously open sourced their work as well, and the models will be available under Apache 2.0 license. Overall, I found this model to be a breath of fresh air. Thank you for watching. If you want more videos like this, please consider subscribing. See you in the next one.